So the loop structure. I think we mentioned this. I think I also mentioned that I need to be very careful not to do this. It's totally okay to draw the line that goes back up. That's what makes it a loop, right? If it was a, I better just close this. If it was just an if statement, they would loop. I mean, they would not loop. They would join back together in an oval underneath. I mean, a little circle underneath and keep going. But since it's a loop, it comes back. You can draw the loop coming above everything, or if you want, you can kind of just draw it hooking up to the diagonal line. That's how I prefer because it's fewer angles and stuff. Doesn't matter. Do it the book way, you're totally golden. Do it my way, you're even better. No, I'm kidding. So there are two kinds of loops in our language, this particular language that we're using. There are more kinds of loops in other languages. But honestly, the kinds of loops they give us are enough to do anything that we want to do. It's kind of like if you have a truck and you have a motorcycle, you could probably get around and do anything that you wanted to. But if you also had a car, right, and you had, whatever more vehicles, then maybe that'd be great. But with those two things, you could get around and carry things around. Same with loops. So we're on lecture I believe. Two kinds of loops, a while loop and a for loop. A while loop is also known as an indefinite loop. It just keeps repeating until the condition becomes false, whatever the condition it may be. The condition may be until the user types Q, something like that. So a while loop is an indefinite loop. If the book calls it something else, we're going to change its name. But here's an example of it. X is equal to 10. While X greater than equal to 1, colon, next line, print, parentheses, X in parentheses, and then subtract 1 from X. X equals X minus 1, or if you want to do it in a groovier syntax, X minus equals 1, with no space between the minus and the equal. All right, this is my first class. Why is my voice going? And if I run it, it's going to count down from 10 to 1. All right, now that's kind of acting like a definite loop. But the while structure is good for indefinite loops, like asking the user for a test score, but letting them type in Q to exit. We don't know how many test scores they're going to enter. They may enter 1 before typing in Q, or they may enter 500, right? So it's an indefinite loop. A definite loop, a for loop, is very specific about what it does. It steps through a series of preordained data values. And those preordained data values can be a series of numbers, just like this thing was, or they can be a list. Now, we're not going to talk about lists again for a long time, but I'm going to go ahead and let you see it this first time. I'm going to declare a list, and because lowercase l's look like ones, I'm calling it an uppercase L. L equals, and the syntax is very particular. These are square braces, not the curly ones, so they're not shifted. And I'm just going to put some numbers in here. 10, comma, 5, comma, 20, comma, 6, whatever the numbers are, right? And then I'm going to write a definite loop that steps through that list. And when we get to talking about lists more, the book's going to call them arrays, although there's a difference between arrays and lists, and we'll talk about that. Python doesn't have arrays. It has lists because lists can do everything that arrays can do and more. So, now that I have my list for V space in space L colon, now I'm going to read it in English, for V in L colon, in other words, for every value in the list, heck, we could, expand the letter V to the word value, print parentheses value in parentheses. And it's going to print 10, 5, 20, and 6. Or not. Oh, it came here. All right. So we saw that the while loop counted from 10 to 1, and that the for loop spit out the exact values that we had listed, right? And these values weren't mathematically defined. I just typed them in there. I could have put words in there. If I wanted to, I could make this do some counting just like this did. I'm going to make it do some counting, and then we're going to get off the topic. I'm going to copy those two statements, paste them, and I'm going to replace that L colon with the word range, parentheses, 10 in parentheses. So there we go. When it runs, after our little bit of 1, 10, 5, 26, it counted from 0 to 9. But that was a very specific set of values, and there was no way for it to exit early, right? No asking the user if they want to type in Q or, whatever, enter test scores. It did a very specific thing of counting from 0 to 9. Now you may wonder, why in the world that 10 means 0 to 9? Well, a range automatically starts at 0 unless you specify a different starting value by putting a number here followed by a comma. Sure, you can do that, like if I wanted it to start at 1. I could do that, like that, 1 comma. And then it's going to count from 1 to 9. Why is it counting to 9 when that's a 10? Well, the range statement's bottom end is so-called inclusive. If you've ever taken a math course where they use the term inclusive, and I believe on the number line it's filled with a solid dot or something like that. I don't remember. It's been a while. And then this end is exclusive. It quits before it reaches that point. So it does include 1, but it goes up to 9 because when it hits 10, it exits the loop. So that's why it prints 1 to 9, and I'm going to actually put a comment to that effect. Arrange 1 through 9. All right, so this was our indefinite loop. That was our while loop. These are our definite loops, our for loops. So here's a loop structure. While the test condition continues to be true, do some process. For example, while you continue to be hungry, take another bite of food. Right? Indefinite. We don't know in advance how hungry we are. And then since this is pseudocode, we're going to end it with an end while comment. How do I know it's pseudocode? Because it's just written in plain English. We don't see colons and parentheses or anything like that. So combining structures. All logic problems can be solved using the sequence of the three logic structures we have seen. I'm going to go ahead and tack them into our notes. Just again, we've seen sequence, we've seen selection, and we've seen loop. Sequence are just statements one after the other. Selection are the if statements, and loops are, the loops. It's hard to explain what a loop is, right, when you have to use the word in its explanation. So, going back to my code here, 3 kinds of logic structures: sequence, selection, parentheses if, and loop, which we could tack on our while and for. Now your flowchart, if you've done it, was all sequence and selection. There weren't any loops in it. We could have tacked on a great big loop, right? Enter your salary or Q to quit, right? And then it would keep looping over and over. I'm not going to do that yet. I don't want to make this chapter go on longer than it needs to. But that's the idea. Every logic problem can be solved, and in other words, every program can be written with those 3 structures. Now, I would argue that there's a 4th kind of structure, but the book would probably just say that it's a different form of sequence. And that's a module call. remember when we wrote a module to draw a square or something like that? I don't remember exactly what it was, but in the Turtle program we had it draw something by calling that function. To me, calling a function is another form of logic structure, but they probably say it was a sequence. So I'm not going to argue with them at this point. So by stacking your structures, you attach the structures end to end. The end of structure statement indicates the end of the structure. You can have end if, end for, and end while. That doesn't mean in your program you have end if, end for, and end while, but if you like them there, which I sometimes do, you can add it in as a comment. And an end if in a flowchart is just a little circle. And the end while, there really isn't an end while. You can kind of see where it end whiles by how the line hits the loop. So stacking our structures. Step A, step B. Is there a condition? Yeah. If that condition is true, do step D. Where'd step C go? Okay, condition C. Else do step E. And then come back down here and we have a loop. Condition F? Yeah, if that's true, do step C or G over and over and over again until condition F is no longer true. Now maybe you can see why I personally like putting the words if and while in my diamonds. Textbook doesn't do it. I do. I think it's clear if the word if, so that way you instantly understand that the diamond is that and that the loop is that, but whatever. You know, these flowcharts are for our purposes. So any individual task or step in a structure can be replaced by another structure. If we went back here, say that step A for some reason needed to get really complicated. For example, it needed to be a loop that would calculate the value of pi because for some reason we weren't going to be able to import the value of pi or accept 3.14159. That would be a loop. There is a loop, an algorithm that will calculate the value of pi, which sounds weird, right? It's a constant, but you have to figure out what that constant is somehow. So it could be a loop. Step A could be deleted and a loop inserted there that would calculate pi until it was precise enough, right? And if step B is a printing statement, like print results, but what if those results were a list, like we saw? Then it might be a for loop that would print out all of the steps of that for loop, right? So you can delete individual blocks and insert structures. Hope that makes sense. So any individual step in a structure can be replaced by another structure. You're making the program more complicated. So nesting a structure is when you put one structure inside another. That's when you indent the nested structure statements. Here this statement is nested inside that condition. But you can nest another condition here if you needed to. Right? If weather is hot and if I have the day off, then go swimming, right? Two different if statements. One is nested inside the other. So, hot equals true with a capital T. Day underscore off equals true with a capital T. If hot, colon, print, it sure is hot, end quote, in parentheses. Now we're going to check to see if we have the day off so we can go swimming. If day underscore off, colon, print, parentheses, quote, let's go swimming, end quote, in parentheses. Now I'm going to add my little end of loop structure words, even though they're not necessary in Python, so I'm making them comments. End if, and here's another end if. Sometimes I can't remember whether I like leaving the spaces in or out of the word end if. Anyways, you understand what a nest is. It's eggs inside a nest. Or you have those little Russian dolls and you have the baby inside the bigger doll, inside the bigger doll, inside the bigger doll. This if statement is nested inside this one. If you're going to draw, there's a flow chart, You'd have one if, and it would come over here, and it would have another if, right? And here would be the print it's hot. Then they would join back together there, and these would join back together there, like that. And it's much harder to see when I've got these black writing all over the place. All right, hope that makes sense. This is nested in here. This is nested here. And quite often you call that the body. All of this is the body of that if statement. This is the body of that if statement. The whole body here might be inside a loop, right? And then when it gets done up here, you know, that was just one day of summer. You can come back up here and we keep doing this all summer long. Hope that makes sense. Hope that makes sense. Here we have a loop. An if statement is nested inside the body of the loop. This if statement is nested inside that if statement. So this is the entire body of the loop from there to there. Make sure I don't have any syntax errors. There we go. Sure is hot. Let's go swimming. Now we don't have any else's here, but we could put some else's, right? Else, print, I wish I had the day off, right? Something like that. But I'm going to leave it alone. I'm just going to put a comment that this demonstrates nested ifs. If logic. Demonstrate nested if logic. These are what are known as flags. Right? Is it hot or not? We have flagged a condition to say that it's hot. More technically, they're known as Boolean variables. Flag is a little bit of a more colloquial term. Right? So that's a Boolean variable called hot that holds a value of true. A Boolean variable is kind of a mathematical value, but all it can equal is true or false. So if you go on and take discrete math or some class that talks about Boolean math, then Boolean math is a universe in which there's only two possible values, 0 and not 0, right? And 0 means false and not 0 means true. But instead of putting 0 and 1 here, we're just going to go ahead and use the words true and false. This stuff is nested inside the if, just like over here in our pseudocode, these steps are nested inside the if. This loop is nested inside the if. So the body of the if statement is all of these statements. The body of the loop is that statement. Now we're getting even more complicated, it looks like. We have an if statement here. We have another if statement here. Except it looks more like a loop. See, I wish the words if and while were put in here. That's an if statement. And here's a while statement, and it keeps running while that condition is true. And part of its body is to have another if statement. So we're kind of 3 levels of indentation deep. I'd have an if, and then I'd have a while that was indented under it, and then I'd have an if that was indented under that. Tab, tab. I guess that's 3 levels. So structured programs have the following characteristics. They are all combinations of the 3 basic structures. Each structure has a single entry point and a single exit point. Now I read Lucidchart's documentation. Supposedly we can get a educational account by going up to our settings. I really need to get rid of the thing that's making everything I have black rather than white. Wasn't that teeny tiny? Alrighty. So like if I click on my name over here and click account settings, there should be a place where I can request student account. Where would that be? Request student account, Lucidchart. Oh, fine. It's not showing up as easy as it did when I looked at it downstairs. Get started with an educational account, Lucid chart. Follow the instructions. Higher education students and teachers. Click sign up for free. Want your account, click on your name, navigate to account settings, and click get a free educational upgrade in the bottom left navigation. First one to find it wins. Tell me how to do it.
It may not show up there if you already have the.
Right, I already have an account, so I may not be able to see it.
Payment history, and it says level Lucid Chart Education RP.
Oh, so where's that? Let me see it.
It's under payment history, so I'm guessing you have to go to the payments and then request it from there.
Okay.
That's what I'm guessing.
Yeah,
I don't know.
So yeah, if you have a payment history, click on that, and maybe there's a request educational account. Well, you don't have a payment history.
Did you use your Rose email address?
Might have to do that.
Yeah. Log into this
I signed up through 365, and then I just used my Rose account, and it gives me, I don't know, it just did it,
Yeah.
and it works great.
All right.
But I
You
used
use your Rose account
365 to
it
sign
gave
up,
you.
and I used my Rose, yeah, I used my
All right.
Rose account.
Could be that that's the golden ticket. Use your Rose account. Maybe it sets you up with an educational automatically. All right, so the real reason I went over here is because I just wanted to show y'all, you know, every semester I wind up drawing more flowcharts, so I should have about 7,000 of them now. Maybe. Right, and so I should be able to pick any flowchart here. I'm looking for a complicated one. And we can see that they're all just combinations of the basic structures, except this one doesn't have any loops. And for some reason I drew huge circles. But anyways, and I was trying to get it all on one page, so I drew connectors up at the top, right, and the bottom, and then added dashed lines. Go from there to there. Wow, I sure was fancy. You wouldn't necessarily add to do that. I could have left the dotted line off, but as long as I had, you know, a circle and an A there, you would understand. Absolutely no reason for y'all to do that, right? You can just create as many pages as you want. But right, this step may just have been a single block, and then I figured out that it needed to have more complex logic. And so I replaced that single block with a more complicated structure. So any structure can be nested within another structure. Structures can be stacked or connected to each other only by their entry or exit points. This is a very important point. Every statement you draw, except for a loop, can only have one line going into it. And every statement you draw can only have one line leaving it. And we can kind of see that. Although this doesn't have any loops, every block has exactly one line at most leaving it. And since there are no loops, every block has at most one line going into it. And the only one that doesn't have one line going into it is a star. So if you wind up drawing something that has three lines leading away from it, it's wrong. If you draw something that's got 2 lines going away from it and it's not a decision block, it's wrong. Decision blocks are the only ones that can have 2 lines going away from them. And no more than 2. They have to have 2, right? A yes and a no. All right, let's go find. You would think I would remember how to close the document. I guess I can always just close the page. And here's another simple example. But, right, the only one that's allowed to have 2 lines leading away from it is a while. The only one that's allowed to have 2 lines coming back to it is a while. Even an if statement can only have 1 line going into it. Right, but why does a while have 2 lines coming into it? Because it's repeating, right? If there was no way to get a line coming back to it, then it wouldn't be able to repeat. So the reason I'm trying to I keep repeating that is because I know, especially if I ask this on an exam and when people's brains start getting frazzled, they'll draw blocks with several lines going away from it. Just because, right? And so you got to train yourself to think the only thing that can have 2 lines going away from it is a decision, is a diamond. And don't worry, I won't throw it on an exam unless we've got lots of practice at it. Not just drawing one, right? So, using a priming input to structure a program. You know how you have to prime a pump before you can get any water out of it? In the old days, you had to pump the gas before you could start the car. Nowadays, that's probably a really bad idea. Anyways, that priming is getting the first input data record. And it's outside the loop that reads the rest of the records. So this could conceivably be some kind of input statement, like input score. And this could be while score greater than 0, or score, greater than or equal to 0. If you enter a negative score, it means you want to exit the program. And then if that's true, you're going to print the score. And by the way, if you need to change a block because you chose the wrong block, you don't have to delete it and redraw it. You can just right-click on it and do change shape. And I'm going to make it another input block that asks me to input the score again. So this is the priming read. It's the first read. It's in the wrong shape, isn't it? Change the shape. Put it in that. All right. So here we go. You got to input the score at least once. That's the priming read. Because if it went here and it said if score is greater than 0, how could it print the score? It never input it. And you might think to yourself, well, okay, I'm going to put the input inside here. Well, then that wouldn't let them enter negative 0 as their first piece of data, which maybe they do. Maybe they need to. There are other ways of structuring loops. Priming reads, priming loops aren't the only thing, the only way of structuring loops. Now, when you have a priming read, quite often you have what's known as a Sentinel value. A Sentinel value is one that causes the input to quit, right? It's got to have some way of quitting. Might be the end of the file, right? It's reading all the way to the end of the file. Or you're asking the user to enter data. The Sentinel value might be Q for quit, right? Or it might be -1. That's the score that they want to enter in order to terminate the loop. That's called the Sentinel value. The Sentinel value is a special piece of value that doesn't actually have meaning as data, right? I can't have a -1 as my score. Your teacher's a real jerk if he's giving me -1s, right? Or I couldn't have a score Q, right? So a Sentinel value is, I don't really like calling it invalid data, but it's not valid data, right? Because it exits the loop. It's a special value that causes the loop to exit. Let's run with that. So what's a priming read? I think I'm just going to enter some comments like that. Triple quote. Priming input. And then put before the while to get the first piece of data. Sentinel value. A special value that causes the loop to end. Like enter score or -1 to stop The -1 is the Sentinel value. The book shows reading from a file, and the end of file is the Sentinel value. It can be anything you choose that should terminate the loop, as long as it makes sense to the user. And a Sentinel value should not be a valid piece of data, right? Not a valid test score if you're letting them exit the loop. Wouldn't make sense to say type in 90 to exit the loop. 90 might be a valid test score. So watch for unstructured loops that do not follow this order. First, ask your question, then take an action based on the answer, and then return to ask the question again. Now before long, we're going to write a loop that violates this order, but for now we'll just stick with that. Our input loops will probably follow an order like that. And if I found my lucid chart again, I'd be able to find that, right? Input the score, so that's before the loop. I do something with the value, and then I do the input again, just like they say. That's a structured loop. So, why do you use structured programming? Well, for one thing, languages nowadays force it. But why do languages force it? Because unstructured programs are confusing. If you have these programs with lots of go-to statements or jump statements or stuff like that, then it can be incredibly difficult to figure out the logic, to figure out what's going to happen one after the other. It's professionalism. Other programmers expect it. Again, if your language is enforcing it. But anyways, even if your language didn't enforce it, then you would want to be a good programmer. You would want to put it in there. Efficiency, maintenance. That's one of the best reasons to have nicely structured code, is so that if something was broken, you would know right where to go in order to fix it. And then modularity, easily broken down into modules. If I went here and that thing right there turned out to be very complicated, I could just turn that into a module. A module is a separate column, and a call to that module, and then it returns when it's finally done doing however many steps it needed to do. So structured programming means that it can have calls to modules. If it is going to have a call to a module, it's done in a special shape, like that. It looks like a math block, but it's got bars. That seems to be a new rat phrase. If you're really skilled, MC, then you say that you got bars. Anyways, the textbook shows a single bar along the top. This drawing program gives you 2 bars down the side. Same thing, as long as it's got bars, eh? And this here means call a module. And I colorized it to make it super easy to spot, right? So when it's going to do birthday, it jumps over here and it does all this stuff, and then it returns so it can come back over here and then call the birthday module again. And then it'll run over here, do all this stuff, and return, and then comes back. That's why I consider modules to be the 4th programming structure, right? Along with selection and looping. Recognizing structure. Seems like we've covered that. So, summary. Spaghetti code. Statements that do not follow the rules of structured logic. Fortunately, the language just flat out forbids it. Programming is so easy anymore. No, not really, because as soon as the language gets better, the kind of problem you solve becomes far more complex. Right, like 70s, when the programming languages are very primitive, what kind of game did you write? Pong and Tank and something like that. Nowadays, very complex programs. So the 3 basic structures, sequence, selection, and loop, which you combine by stacking and nesting. What is a priming input? That's the thing that reads the first input value before going into a structured loop. Why use structured techniques? For clarity, professionalism, right, tug on your tie or whatever, I'm now professional, efficiency, and modularity. Flowcharts can be made structured by untangling logic. Now, I haven't even done that. I haven't even drawn impossible flowcharts and then had us untangle it. They gave us an example of that about trying to catch the dog so that you can give it shampoo. That might be an interesting process to try to structure it. I don't think I'm going to bother. But you can absolutely draw things that don't really exist in terms of structured logic. You can make flowcharts that are impossible to implement in programming code, right? Because the lines go, and connect things up in strange places. Like after you input the score, maybe you're going to lead back up here for some reasons under certain circumstances. That would be very weird. Like if you had an if diamond here, and if that was true, then you might go back up here and do that input again. And if it was false, then and only then are you going to loop, right? Something like that. Just pretend it's well drawn, right? So this is unstructured code. An if statement jumping outside of its block to do something else, can't do that. That's not structured code. So you can easily draw flowcharts that don't wind up being structured code, which in a way is probably an argument for using pseudocode rather than flowcharts. And once your brain starts working in the in the ways of a programmer, you probably won't be drawing too many flowcharts, but they help visualize the code. They are an important thing to learn. 3 structures: sequence, selection, and loop. Seems like we've said that already. And we are done with the chapter. I think since I gave you a homework assignment on Wednesday, I'm comfortable not giving you one today. But I do want you to go and take the quizzes, which are now linked inside CEngage. I'll move them so that they're a little bit easier to find. But you're going to want to do the Unit 2 test and the Unit 3 test. Remember, you can take them over and over until you get the grade that you want, which I recommend doing, right? Why accept a 12 out of 20 if you can go back in and get a 19 out of 20 or a 20 out of 20? It's just a matter of patience, right? And I tell you what, there's absolutely nothing wrong, like if you get to question 17 and you just flat can't get the right answer, taking the quiz 4 times, right? Don't even answer anything else, or give garbage answers all the way through it. Finally find that question, try one test, then try another, and then try the other value, and then go, okay, thank goodness, I finally know the answer to 17. And then take it for real one more time, right? Because if you take it a second time and you get a lower score, it only counts the highest score, right? So you can kind of botch a test in order to jump to the questions that you're really curious about. But on the other hand, there's nothing wrong with answering the questions again over and over and over to burn them into your brain. All right, I think we're done for today. Why don't we